When you see that 50 out of 413 top companies use a specific open-source library, it feels like a seal of approval for your own project. It suggests safety and industry-standard practice. But this statistic hides a dangerous engineering reality. Popularity often masks massive infrastructure costs and latency bottlenecks that senior engineers must architect around. The choice to adopt these tools frequently prioritizes developer velocity over operational efficiency, creating systems where the energy tax on inference runs orders of magnitude higher than necessary for simple tasks. The industry narrative has long focused on training as the primary sink for resources and carbon emissions. We are told that building a model is the hard part. Recent empirical studies from institutions like Carnegie Mellon University challenge this directly by showing that inference costs now frequently exceed training emissions when teams use massive multi-purpose models for routine queries. When a developer deploys a 70 billion parameter language model to answer a simple customer support question, they incur an energy and latency tax far greater than using specialized alternatives designed for speed and size. This is not a marginal inefficiency. It represents the single largest variable in sustainable AI deployment today. Consider the scale of this inference tax. When you treat popular libraries as free lunch solutions without understanding the underlying hardware constraints, your system becomes unsustainable at scale. The data reveals that operational inference emissions are beginning to exceed training footprints across university and nonprofit sectors, where optimization is less rigorous than in commercial enterprise settings. A large-scale analysis of nearly 158,000 repositories shows that while these libraries democratize access, they often introduce hidden complexity and maintenance burdens. The adoption by top firms is frequently driven by the need for rapid prototyping rather than long-term optimization, creating a dangerous gap between what works in a demo and what scales efficiently without breaking your budget or cooling capacity. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This architectural mismatch leads us to a deeper behavioral trap that affects engineering judgment itself. Research into AI decision-making indicates that over 40% of users treat predictive models as infallible authorities. In controlled experiments involving 1,305 participants, this reliance resulted in teams being 3.39 times more likely to abandon safe engineering paths based on an AI's prediction, even when that prediction was demonstrably incorrect. This phenomenon creates a financial penalty where participant earnings were reduced by 10% to 43% due foregoing guaranteed rewards. The bias leads engineers to trust the algorithm over established safety protocols or simpler logic, effectively outsourcing critical architectural decisions to tools they do not fully understand. The result is an engineering culture that mistakes convenience for capability. When teams fall into this predictive authority trap, they build systems where model size and frequent versioning directly correlate with massive carbon output regardless of task complexity. A 70 billion parameter model running on a GPU cluster just to handle a simple classification task is akin to using a nuclear power plant to charge a single smartphone battery. The latency introduced by moving data in and out of these massive architectures becomes the bottleneck, slowing down user experience while draining electrical resources at an alarming rate. This dynamic drives a 30 to 40% annual surge in data center electricity consumption, driven purely by architectural choices made for convenience rather than capability. To solve this, we must shift our judgment from what is easiest to code to what is efficient at scale. Senior engineers need to ask if they truly need a massive model or if a specialized quantized version suffices. The solution lies in adopting specific patterns like aggressive quantization strategies and utilizing inference engines optimized for latency such as VLLM or TensorRT. These tools allow you to run smaller, task-specific architectures that deliver the same functional output with a fraction of the hardware footprint. It requires moving away from the one-size-fits-all library mindset toward an architecture where every component is selected based on its specific cost-benefit profile for the production environment. The ability to explain why a popular library might be the wrong choice for your specific use case becomes a critical career differentiator. If you are building an AI feature for a startup or internal tool and default to the most popular open-source stack, You may inadvertently architecting a system that will become prohibitively expensive as traffic grows. You must understand the trade-offs between training costs and inference costs because they dictate your infrastructure bill tomorrow. Auditing your current stack for these hidden inference costs is not just an optimization exercise. It is a fundamental requirement of modern software engineering leadership in the AI era. The path forward requires treating every library integration as a potential liability if its efficiency profile does not match the task at hand. We must stop assuming that high adoption rates equate to optimal performance for our specific constraints. By prioritizing operational efficiency and understanding the hidden energy costs, we can build systems that are both faster and more sustainable. The future of AI engineering belongs to those who look beyond the download count and audit the true cost of execution in production environments. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.